Yeah, I know this is going to seem like really basic stuff for a lot of you, but believe me, go ahead. This is there will be things that probably on every side that somebody actually doesn't know as well as they should. So we're just trying to like firm up all those things. Right? These are the objectives. You're going to see they come from what would be considered the first couple sections in our little workbook. So let's remind ourselves of some vocabulary kind of words. What in algebra, what do we mean by a variable? Or give an example of a variable. Yeah. Okay, as an example, you might say, and we usually say, X. Okay, there's an example. But, I mean, when it says, just examine the word variable, what does a variable do? It varies, right? It could have different values. And generally, when we start out a problem, we don't know what the value it has. Right? When you're solving an equation, you don't know when you start what is the value. So a variable can have different values. Can have different values right? But it is unknown. I mean, take the distinction between a variable and, for example, this is something that everybody in here has seen, pretty sure. Y equals k times x, right? You did that when you did direct variations. The y and x are variables. The k is not a variable. It's a constant, right? The k is a constant because its value does not vary. It just has one fixed value we don't happen to know when we start the problem, right? So variables vary, right? You can have letters in formulas, equations that don't represent variables. They're actually constants, right? But variables, usually we use x. We use different variables, x, y, z, a, b, c, who knows? Okay, what do you mean by an expression in math? Or give an example of an expression. Yeah. Okay, not an equation, right? Specifically not an equation. An expression is something without an equal sign, right? It could have a bunch of different terms, right, which involve constants and variables and addition signs and subtraction signs, right? But it does not have an equal sign. If it has an equal sign, what do we call it? It's an equation, right? So we're talking just about expressions right now, not equations. We'll get to those soon enough. So something like 2x plus 3. There's an example, right? So there's variables, constants, pluses and minuses, right? And then in parentheses, it'll say no equals, right? Once it's got an equal in it, now it's a whole different animal there, right? There's three kinds of things that we deal with in math. Expressions, which, yeah, we know what that is. We will get to equations, right? Equations are got an equal sign. And the last one will be a function, right? And a function is when you've got like y equals an expression, and that is two variables in it. That's something you have to graph. Okay, in terms of math speak here, what do we mean when we say the sum? What does that word mean? I know you know this. Yeah, it's a result of addition, right? Result of addition, right? And what is a difference? Yeah, result of subtraction. Okay, what is a product? Result of multiplication. And the last one, quotient. Say again? It's a division, right? Result of division. I mean, some of these I know, you know, you know some. Somebody says the sum of, I mean, heck, you see that in not even in a math context. I mean, isn't there a movie or book, The Sum of All Fears? You know, I mean, and you know when you see that, you know what they mean, right? The sum of. You know, remember back to algebra 2, factoring, the difference of squares, right? I mean, it's kind of implicit. You're supposed to understand right away what that means. You can't be stuck on that one word, you know. That's a division, that's a subtraction. Product, I think we're pretty good with. Quotient might seem like a word we don't use very much, but that is part of it. Okay. We good? Okay. Okay, remind what it means to square or raise something to a power, right? What does it mean to say 5 and then have the 2 in that position? Yeah, I mean, what do you call that? It's a square, right? You say 5 squared, which means 5 times 5, right? Which is easy. 5 times 5, 25. Okay, what does it mean if I raise something if the exponent is a 3? Okay, that means we're going to raise it to we're going to multiply it times itself 3 times. Which is 8. And then how about if it's raised to the 4th? 4 times, right? That's what the exponents or the powers do. So 3 times 3 times 3 times 3. Who can do that one? 81. Again, we're not using calculators in here. If you have trouble with that, then sit down and do the calculation. Get practice doing computations. Right? You'll get credit for it. Exponents. Now, order of operations. We always use this as the acronym. Anybody remember a way to remember those letters in order? Yeah, I mean, people usually say, please excuse my dear Aunt Sally, right? And it's telling you from top to bottom, right, the order that you should be doing operations. What does the P stand for? Parentheses, right? Anything that's in parentheses, go inside the parentheses first, right? Parentheses. Okay, how about the E? E for exponent. M for multiplication. D for division. A for addition. We all know these, right? Addition. And S for subtraction. So now it's a little more tricky than that. There's some common mistakes that get made, right? This is number 1. This is number 2. These together are number 3. Right? You go from left to right. If you encounter a multiplication or a division, whatever you encounter first, that's the first thing you do. You don't go through and do all the multiplications and then go through and do all the divisions. Right? These two are considered at the same time as you're looking from left to right. And same thing with the addition and subtraction. Right? This is like together you consider addition and subtraction from left to right. There's a YouTube video. Somebody told me about this once. It said, do you know that the order of operations or PEMDAS is wrong? And I said, no, I didn't know that. He said, oh yeah, there's a YouTube video. It shows you why it's wrong. So of course I went and looked it up, and there is a video that says that. What they said was it's usually taught wrong, so people don't apply it correctly. They're not saying that this isn't correct. They said, yeah, it's usually taught in a way that doesn't properly address this one fact right there. Okay. So, for example, for these 3 right here, let's looking at the letter A. Right, what would be the first thing that we simplify using the PEMDAS? Right, let me write it up here. PEMDAS. Okay, so what is the first? The exponent, right? There are no parentheses, so you jump to the E. 4 squared is 16. So we've got 5 times 7 minus 16 divided by 2. Right? What would you do next? Come on. So what have we got left? We got a multiply, a subtract, and a divide. Which is the first one? You're going to do the multiply, right? From left to right. You know, you're looking at the multiplication and division together, and you're going to say 35. And then you can do the next. 16 divided by 2, 8 minus 8. So that equals 35 minus 8. Quickly. Come on. That's the thing I'm talking about. 27. Okay. Okay, how about the second one? What is the, let's go like this. What is the first operation you're going to do? 12 minus 25 divided by 5. So you're going to do the division first, right? Division definitely comes before both addition and subtraction. So you're going to go equals 12 minus 5. 12 minus 5 is 7. Okay, here's a fraction. And we're going to probably next lesson, next day, we're going to do a whole day of just simplifying, add, subtract, multiply, divide fractions. But it's kind of hard for me to avoid all of them before we get to that. So this is in here. What about when something is in a fraction? I mean, how does the fact that you're doing that, how does that apply when you're applying the PEMDAS? What does the fraction bar kind of do for you? It's kind of telling you that these things are in parentheses, right? So a fraction bar is like an implicit, put the numerator in parentheses, put the denominator in parentheses, right? Don't try to divide, 3 to the 4th divided by 2 or something like that. No, you can't do that. You've got to simplify what's in the numerator first, simplify what's in the denominator first. That will be the P, right? Now, once you get inside the numerator, now you're going to have to apply the order of operations for the numerator. What do I need to do first? 4 plus 3 to the 4th. The exponent, right? You're not going to go 4 plus 3. You're going to go 3 to the 4th. So this will be 4 plus, and 3 to the 4th is 81. Okay. And now we can simplify the denominator in one step. 7 minus 2 is 5, right? And 81 plus 4, 85. Okay, and who can do 85 divided by 5 quickly? right? If you had to, right, you could divide 85 by 5, right? It goes into the 8 once, subtract, right, goes into 17. And, I mean, in my mind, what I do for that? What is 100? How many times 5 is 100? It's 20, right? So 85 is 15 less, so that's 3 times 5 less. So 20 minus 3, 17. I mean, that's what I did just instinctively. Yeah, I should be able to do that kind of thing, but. Okay, so this is 85 times 17. All right. Okay, what is the value of the expression? So now we're evaluating, right? Evaluating an expression means substitute values for the variables and then see what it equals, right? Evaluating means right. In this case, it's x equals 5, y equals 2, and here's your expression. What are we supposed to do with the 5 and the 2? Plug them in, right? Everywhere you see an x, put a 5. Everywhere you see a y, put a 2. And so this will be 5 squared plus 5 minus 12 divided by 2. Okay, now it's an order of operations. Right? Which operation am I going to do first? There's an exponent, right? So you're going to go 5 squared, 25 plus 5. I'm going to just take a line to minus 12 divided by 2. What would be the next operation to do? There's a plus, there's a minus, there's a divide. What goes first? Divide, right? So this will be 25 plus 5 minus 6. What's that? Oh, you're right. He's right. I'm wrong. Let's go back and okay, 2 squared, right. So actually, at the first step, let's square, we used to do the exponents twice, right? So I should have said this is 25 plus 5 minus 12 divided by 4. Okay, now divide, right? 25 plus 5 minus 3. Okay, now left to right, it's all addition and subtraction. So you're going to go 25 plus 5, which is 30, minus 3 is 27. Okay, now, this is the same problem because it's something I wanted to show, because this is, the one in the last, you probably wouldn't have made a mistake that one anyways. Where we make mistakes, and a lot of times the reason we make this mistake is because we put it in the calculator. And the calculator misleads us. What if that's not a 5? What if that's a negative 5? Right? Then in the first step, right, when I put in negative 5 here, negative 5 squared plus negative 5 minus 12 divided by 2 squared. Most of the time, students are putting negative 5 and then hitting the square button, and it says negative 25. What's wrong with that? It's actually negative 5 times itself, and a negative times a negative is a positive, right? That, really, to be careful about it, put it in parentheses, right? Now this is 25, and then plus a negative. That's like the definition of subtraction, right? So I'll say minus 5, and then minus 12, 12 divided by 4. That was the same as before. So this is 25 minus 5 minus 3, which is, yeah, I mean, if you do it one at a time, you're going to get 20 minus 3 equals 17. Again, I would guess that for a lot of you, you're not really into showing work, but it's another one of those just like good student habits to have, especially in a math class. It's not meant to be punishment. It's not a sign of weakness. It's a sign of strength. You know, I show work, and I'm really good at this stuff, and I would not skip the work. Not even a little step. It's always that little step that messes up everything that comes after. Okay. And okay, how about this one? xy in parentheses squared, x equals 5, y equals 2. Again, when we say evaluate, what are we going to do with the 5 and the 2? We're going to plug in for x, plug in for y, right? So now I'm going to do this twice, right? So this could be 5 times 2 in parentheses squared, which is 7 squared, which is 49. Agreed? Now, what you might try to do is go, oh, that's going to be like x squared, y squared, right? What do I got wrong there? You know, I'm a math teacher making more mistakes than, that was a 10. So you got to catch me from making stupid mistakes, which is 100. Right, so this thing now becomes 5 squared times 2 squared, which is 25 times 4, which is 100. Right. So the bottom line, it doesn't matter which way you do it. Right. You could have thought of it like x squared, y squared. Okay. Now, what if it says x plus y squared? Right. Substitute for the x and the y. That is 5 plus 2 squared, which is 7 squared, which is 49. But would that have been the same thing if I did x squared plus y squared? Can you say that x plus y in parentheses squared equals x squared plus y squared? And the answer is no, you can't do that. Remember that when you have a square, it means multiply that thing by itself. And x plus y times x plus y is a FOIL. It's not just x squared plus y squared. I mean, see what happens now if I plug in 5 squared plus 2 squared. I get 25 plus 4, which is 29. Right? That is not the same thing. It matters. Right? So don't think of something like this as, oh, I'm going to distribute the 2 inside. You can do it up here, but when there's more than one term, terms are separated by plus or minus, then you can't do that. You got to just take x plus y times x plus y. And we'll do more of that later. And let's see. And that was all I wanted to cover like as a lesson today. Right? Those are the objectives we looked at the beginning. For the homework, we're going to work out of workbooks. And, you know, you should write your name on the inside. You can write on them. You can write all over them if you want, but the homework should be on a different page just because they don't actually give you room to do all the work in the book. Not on every page. Some of the stuff we're doing today, yeah, it would work. And, okay. There you go. Chop them. Oops. There you go. There you go. In a second. Let me get this done. Okay. So that is this is the homework. It's coming from page 1, 3, and 7. You probably find it's pretty easy stuff. I mean, I'm not trying to be hard about it. But again, the point is to not use a calculator. Do calculations by hand. That's how our tests are going to be. They're not going to be overly difficult calculations. Okay, so you should work on this now. And we will, let's say at about 10, 15 minutes, we're going to have a timed math facts, like a multiplication tables thing. Yeah. Yeah, you could write in it. Write your name on the inside cover so I can get it back to you if you lose it. If you don't have it on any particular day, just grab another for that class that day, okay? These are expendables, and nobody's using them, so.